looking at the median, quartiles and percentiles in more depth, you can use the probability density function. The median, you integrate between the lower limit and m for median of f of x dx and put that equal to a half and then solve that. If you've got the cumulative distribution function, all you have to do is substitute m into it and put it equal to a half, then solve it. Lower quartile, integrate between the lower limit and q1 for the lower quartile and put that equal to a quarter. Upper quartile between the lower limit and q3 and put that equal to 3/4. The 20th percentile, integrate between the lower limit, and we're calling our 20th percentile y, so integrate between those two limits and put it equal to 0.2, since 0.2 is our 20%. It's easier if you have the cumulative distribution function, because all you're doing is substituting and solving an equation. There doesn't have to be the integration before. So to find the lower quartile, you just substitute in q1 or whatever letter you are using to denote the lower quartile, put it equal to a quarter and then solve it. For the upper quartile, because that's 3/4 of the way through the data or through the probability density function, you just put it equal to 3/4. 20th percentile, you put it equal to 20% or 0.2. Because of the nature of the equation you are likely to be solving, if it's a quadratic, you may get two solutions for m. With that, only one of them will be within the range of the given limits, so that's the one you choose. So in this example, we've got a PDF probability density function of 4x times 1 minus x squared, and that goes between 0 and 1, and then a probability of 0 otherwise. And we want to find the median. So we're going to do it the cumulative distribution function way. So I'm going to find the cumulative distribution function. So f of x will be the integral between the lower limit, 0, and x as our function with a different letter in. I've chosen u, so 4u brackets 1 minus u squared du. Take the 4 outside and we get u minus u cubed to integrate. Integrate those, we get u squared over 2 minus u to the power of 4 over 4, and that's between the limits of 0 and x. Substituting in 0 and x and simplifying, you get 2x squared minus x to the power of 4. So our cumulative distribution function, capital F of x, is 0 for anything less than our lower limit of 0. It's our function 2x squared minus x to the power of 4 between the range x goes between 0 and 1, and then it's 1 for anything above 1, so 1 for x is greater than 1. So to find the median, all we need to do, using the letter m, is substitute m into here and put it equal to 0.5. So we get 2m squared minus m to the power of 4 equals 0.5. Rearranging it, so you get a quadratic in m squared. So that's m squared squared minus 2 lots of n squared plus 0.5 equals 0. Just to make life simpler, double everything so you haven't got any decimals in there. So you get 2m to the power of 4 minus 4m squared plus 1 equals 0. You can then put that in the quadratic equation. So we know that m squared is minus b, so 4 plus or minus the square root of b squared minus 4 times a times c all over 2a. And that gives us two values for m squared. M squared can be 1.7001 to 5 significant figures, or 0.2929 to 4 significant figures, either of those two, which means that m is the square root of those. So m is plus or minus 1.307 or plus or minus 0.541. So our range is between 0 and 1. So 1.307 and minus 1.307 are both outside that range, so M can't be that. Minus 0.541 is also not in the range, so that leaves plus 0.541, or it leaves the median is 0.541. You can use continuous random variables to see whether the median is above or below a certain number by comparing your probabilities to 0.5, because you know the median must have a probability of 0.5 because it's halfway through the data. So if you look at the probability density function of 1 over 21x squared for x lying between 1 and 4, if we want the probability x is less than 3, integrate between 1 and 3, 1 over 21x squared dx, and that all comes out to 26 over 63. Because 26 over 63 is less than 0.5 or less than halfway through the data, then the median of x has to be more than 3. Because 3 is less than halfway through the data, so the median must be more than 3.